today is look at the laws of indices and just complete that off. We had that problem that came from the bird book last week, and that there aren't many mistakes in there, but there are an odd one or two, and we just happened to find one. And then we're going to look at solving single variable equations and transposing and rearranging formulae. Okay. One thing I do want to say is, at the moment, the pace I'm having to go is a bit slow, and I'm soon going to have to speed up. We're going to have to get through everything. Okay, it's both in this and the science. So we've got to work hard, and I think you guys have got to do some work at home, particularly using the Khan Academy stuff. That's what we do. All right. Because we've gone by what I've done on the other courses at this level. All right. So on the board, that was one problem we had to go at last week. So I've left that on this week's notes. I'm not proposing to dwell on that. What I want to do is just clear up this issue with this, and that where he'd gone wrong, if you look at your handout, it's got that power of minus a half on the C, and that should be on the B. I've got the solutions to all the work solutions to his problems, and in the work solution he's got it right. Yeah, but in the book, the question is written out wrong. The C is in that power of a half is in the wrong place. And before you start that problem, I asked the question, why is the answer plus or minus 4.5? And that's kind of why I wanted to pick that one out as an example. Yeah. So we'll work through that now, and then I can explain why that's plus or minus 4.5. All right. So we've got I to the 3 over 2 times B times C to the minus 3, and all of that is multiplied by A to the half, B to the minus a half times C. And remember, we can only multiply things where we've got the same base. So we can multiply the two A terms together. So what do we get when we multiply A to the 3 over 2 times A to the half? What we got to do with the indices if we're multiplying? I'll give you a handout this morning with help on there. What we do, sorry? From now on, when I've given handouts out to the start, I'll put the remainder on the back desk over there to be picked up when you come in, all right? So what do we do when we multiply two numbers together? We add the indices. So what do we end up with here? We've got 3 halves, and we're adding on another half. So we've got 4 halves, which can be better written as not 2a, a to the power of 2. Yeah? All follow that? And then we've got b, and b to the minus a half. What do we end up with? Remember, what index could I put on that b and that'll still be equal to b? 1. Yeah. Any number to the power 1 is equal to that number. So applying the rules of indices, I've got 1 there and minus a half there. So what do I end up with for b? Yeah. And then c to the minus 3, and that's effectively c to the 1. What do I end up with? C to the minus 2. Yep. How else can I write? Could I write that b to the power of a half? Sorry? No. In the book, in his book, in your handout, I give you last week. Find this problem. So far, we've got here a squared, b to the half, c to the minus 2 is a simplification of that term. So, but there's another way that I can write b to the power of a half, and there's another way I can write c to the minus 2 if I want to. Just checking on what you remember from last week, sorry. You could put 0.5, but that's not what you would normally do. There's a completely different way you can write it. What are fractional powers? Look at your handout. You can reciprocal c to the minus 2, so I can write, keep that as a squared, leave b for a minute, and I can write that as 1 over c squared if I want. Right, what about b to the half? Square root. That is exactly the same thing. Yeah. X to the a of a b can be written as x to the power of a and take the b root. Yeah, that's the law. So what I've done, we've done there, is that's the square root. Remember, we don't bother to write the 2 on the square, and the index of the numerator is 1, so we just write b. So that's how we can write that. Okay. Then, in the problem, it says solve that or evaluate it when a is equal to 3. So we're looking at 3 squared. B is 4, so it's the square root of 4, and C is 2, so it's times 1 over 2 squared. Yep. What do 3 square equal? What does 1 over 2 squared equal? 4. What does square root mean? What is the square root of a number? What is the square root of 4? In numerical terms? 2, yeah? Why is 2 the square root of 4? Because it's 2 times, it's the number you multiply by itself that equals 4. Yeah? So we can do 2 times 2 equals 4. What else can we multiply together and get 4? No, it's got to be just one number multiplied by itself equals 4. Minus 2 times minus 2 is equal to plus 4. Yeah? So whenever you do a square root, you might not be interested in a negative solution, but they're always the square root of 4 is equal to plus or minus 2. Yeah? So the solution to this problem is that is plus or minus 2. Yeah? What is the answer? 9 plus 2. Yeah, but not sorry, 9 times plus 2 is 18. Yeah, times a quarter. Yeah. 9, so it's plus 4.5. 9 times minus 2 is minus 18 times a quarter minus 4.5. Yeah, so because that square root is in there and that multiplication makes the answer plus or minus 4.5. Okay. So you'll work with problems where, although you're, let's say, a quadratic equation and there's a plus or minus answer, but you may not be interested in the negative answer. Generally, you're not interested in, if you're working on a problem that involves time as your independent variable, you're not interested in negative time usually. So you throw that solution away. But you should always be aware that when you take a square root or any even root, so the 4th root, the 6th root, 8th root, there's going to be a plus or minus answer. When you're taking the 3rd or the 5th root, the answer is not plus or minus. Okay? That more on that as we work through some problems later on in the module. All right. So that clears that issue up we had last week. Hopefully, we move on. So solve 6x plus 1 is equal to 2x plus 9. What does it mean when we say solve in terms of that problem? Yeah, find x. That's what solve means. Find x. So what are we going to do? Find x. We've got 2 x's on there. What we got to do with them? Minus 1 for both sides. Yeah. So 1 is added to that side. So if we take 1 from both sides, what do we end up with? Yeah. Because what we're effectively doing, just to clear that up as we're saying, we're putting minus 1 there and we're putting minus 1 there. What we do to one side, as long as we can do anything to one side, as long as we do the same thing to the other. Yeah. So that effectively cancels that 1 and takes 1 off that 9 to make it 8. All follow that. Yeah. Where do we go next, pi? What sign could I put in front of that and still be the same thing? Is it plus or minus 2? It's plus 2, isn't it? We don't write it, but that's what's really there. So if I want to get rid of that 2x, what have I got to do to this side? I've got to take 2x away. So if I do that, I must take 2x from that side. So subtract 2x from both sides. Yeah. So what we end up with is 4 is equal to 8. Yeah. Because that cancels, that cancels. Yeah? So now what's the last thing we need to do? Divide both sides by 4. 4 over 4. That and that cancel to leave x equal to 8 over 4 2. Yep. follow that one okay. And remember, we're going to look at formulae where we're just using algebra letters shortly and rearranging those. Here we've got some numbers that we're going to solve. Alright? But remember what it is if you're attached by plus, you've got to take away, and you're almost working reverse by big mass that we talked about. So you can do the plus and the minus moves first, then the multiplication, divide, and the indices last. Alright? And inside brackets last as well. Alright? So, what about 3x minus 2 equals 9? 3 brackets x minus 2 equals 9. What will we do to that first? In what way? What would you do with a bracket? If you expand the brackets, you could do it that way. Let's just take. So what you're saying is expand the brackets, yeah, guys. Oh, we'll deal with it if there's a problem in a minute, right? Toby says we try to expand the brackets here. So we've got to do 3 times x. 3 times minus 2 is minus 6 equals 9. Actually, with this problem, that doesn't cause an issue. But sometimes, well, if you had two sets of brackets, or if you had an x outside the brackets, you're probably going to make the problem bigger. So we'll probably come to one like that later on. But we'll carry this on. So what do we do now? Sorry, add 6 to both sides. So we get 3x is equal to 15. Divide through by 3. So that leaves us x is equal to 5. Yeah? Okay. Now, the alternative method, and probably to get in your mind before you get on to more tricky problems where you'd have to go this way, we add 3x minus 2 equals 9, yeah? Deal with things outside the brackets first. So, divide by 3. Yeah? So if we divide that by 3, those two cancel, and that one becomes 3. So we end up with brackets can go then, x minus 2 equals 3. And then plus 5 to both sides. Sorry, plus 2 sides. We get x is equal to 5. Yeah. So in that case, there were 2 different ways you could do it to get the same answer. And sometimes, with a problem, you might try something that doesn't work, you have to go back, try a different route, if it's a more tricky problem. Okay. Usually, when you're trying to rearrange, that's the laws of precedence that we have, where you deal with things in brackets first, then indexes, then divide and multiply, then add and subtract. When you're rearranging, you have to work with that almost in reverse order. So do the things outside the brackets first. Start with any addition of subtraction, then get rid of any multiply and divide, then do the stuff inside the brackets. Once everything's gone outside the brackets, remember, brackets aren't needed anymore. Okay? So as soon as that term's gone there, that 3, don't need the brackets around the x minus 2 anymore. The other thing to it's important to remember, just as a point to remember, if you see this or similar, right, that line being over both of them infers brackets around that term. So it's 1 divided by all of that. Yeah. Okay, you don't normally put them. Sometimes I put them in just to clarify that there's a bracket around that term. Right. Same as if there's a term inside a square root. It is x plus 2 all square rooted. Because that line is over all of it. Yep. Okay. Can I move on? Yep. Right. 3 over x is equal to 4 over 5. What ideas have you got for solving that problem? Okay, multiplied by x. So we end up with 3 is equal to 4x over 5. Next, what would you do next? Multiply by 5. Yeah, we want to lose this. So if we multiply this under 5, 2 times 5 there. Yeah. You do times 5 by there, they cancel out. Yeah, but we must multiply that side by 5. So we have 3 5s at 15 is equal to 4x. So this is times 5. Divide by 4, we end up with x, and I'm a bit funny, I like to keep a variable on that side. But x is 15 over 4. 3.75 if you like decimals. Yep. Now, just going to go back to the problem. And this one's not tricky to do like that. 3x, 3 over x is equal to 4 over 5. Yeah. When your term that you want to find is on the bottom of a fraction on its own, there's a quick way that you can deal with that. You can invert both sides. Yeah. So you can say x over 3 equal to 5 over 4. Yeah. We've immediately got x on top where we want it. And then multiply by 3. Give us x is equal to 15 over 4 equals 3.75. As long as you turn the whole thing up the other way, okay? What happens if I invert a constant? What do I have to write if I invert 6. I can say that 6 is 6 over 1. Now what happens if I invert it? If we invert that, it becomes 1 over 6. Yeah? Just another thing to remember, that a constant can be written as a fraction with 1 as the denominator. And then you can invert it. That becomes 1/6 or 1/7 or 1/8. That number. Right. And it's all about having the tools to manipulate the equation that you've got into the form that you need it to solve the problem you're trying to solve. And just about everything we're going to do in maths involves some algebra of some sort. Okay, so whether you like it or not, you need to get comfortable with it. Can I move on? Right. Something a little more tricky still now. We've got 2y over 5 plus 3/4 plus 5 equals 20th minus 3y over 2. Oh dear. Where are we going to start? What needs to be the overall initial aim here? What's the overall aim to be able to, we want to find y, yeah? But we got 2 lots of y in 2 different places in the equation. So the initial aim is to get them together, yeah, and as a factor. So if we need to, we can factorise. So we've only got 1 lot of y. Yeah. So where would you like to start with that problem? We just go one step at a time so nobody gets lost. Move to 5. Yeah, you can do, yeah. So we'll keep 2y over 5 plus 3/4. So take the 5 away. So let's write down what we're doing. Subtract 5. Yep. So that 5 we're going to have on the other side, 1/20th minus 3y over 2 minus 5. Next. Yeah. Yeah. We want no, in the end we want no constants on that side. We want all the y term on that side. We got plus and minus at the moment, so we've got to get rid of all the plus and minus on this side. If you take away the 3/4, we want them, and we'll only have that y term on that side then, won't we? Yeah. So minus 3/4 leaves us 2y over 5 is equal to 20th minus 3y over 2 minus 5 minus 3/4. Next. Remember, we need all the y terms together. If we multiply by 5 now, I'm just going to show you what you'd have to do to multiply both sides by 5. Right? you'd have to put brackets around all of that and multiply it by 5. Has that helped you get that y term over with the other y term? Because if you multiply those brackets out now, you're going to end up with 15y over 2. Hasn't done anything. You would get there in the end, but it's not the right way to go. Yep. Yeah, if we add 3y over 2 to both sides, we end up with 2y over 5 plus 3y over 2 is equal to a 20th minus 5 minus 3/4. What can I do to that left-hand side now? You could go with the common denominator route. Is there something else you could do? Probably the best, actually. What's the common denominator? 2 and 5. 10. So if we want to write both these fractions over 10. Yeah. So what have I had to do to this 5 to make it equal 10? Yeah, so you've got to make that, multiply that by 2. What have I done? Yeah. Because I had to multiply that 2 by 5, so I've got to multiply the 3 by 5. And all of that is equal to 1/20th minus 5 minus 3/4. Yeah, so we can now add these together. So 19y over 10 is equal to 1/20th minus 5 minus 3/4. Multiplied by 10. So that's 19y is equal to 10. Quickest to multiply it all by 10. So stick it in some brackets and put the 10 outside. We want to get the y on its own. Divide by 10. Yeah. 19, sorry. To finally end up with y is equal to 10 over 19 means if you so want to, stick that in your calculator and get an answer. Okay, what we're going to move on to now, something you really do have to become comfortable with, and that's the algebra involved. It involves doing what we've just been doing, but with expressions that are just letters representing variables and constants, and that's transposing formulae. For instance, gents, the formula for the volume of a cylinder is V is equal to pi r squared times the length. So it's effectively the area of the end multiplied by the length, volume of a cylinder. Volume V is what's known as the subject to this formula. That's what we're going to find if we use it. So it gives the volume V in terms of the radius r and the length L. If we knew the volume and the radius but wanted to find the length, we would need to rearrange the formula to make L the subject. Okay? So what it's about is, been doing, operations in mathematics have opposites of each other. So if we've got something added, we move it by subtracting, and vice versa. If it's subtracted, we add. Multiply and divide are opposite terms. We multiply 2 by 10, we get 20. We divide 10 by 2, we get 20 by 10, we get 2. Yeah. All right. Square. And square root are opposites of each other. So if we've got a term squared, we want to get rid of that square, we take the square root of it. We've got a square root and we want to get rid of the root, we square the problem, and it cancels. Yeah. All right. Anyone know any more? Yep. So I'm going to put x to the end. So as any index, it's the nth root. Yeah. That's me counting. What does that mean? ln. Yeah. It's the natural log. Yeah. What's the opposite of natural log? No. That's an answer like where's x? That's here. What is pi? Something with apple in it. Natural log, it's the log to the base e, so e to the x, e to the power of x is the opposite of that. But log, we don't put the 10, but the base 10. If you look at your calculator, right, logs, look at the log button, the shifts function will be 10 to the x. Look at the ln button, shift function will be e to the x. Yeah, for most of them. And then we won't do them all, but sine. No. Yeah. that's what you got on your calculator. And then you've got cosine and cosine to the -1, and tan and tan to the -1, and so on. Yep. Majority of some are separated, the real common ones separated onto their own keys, but in the case of these two for sure, ln and log and sine cosine functions, they're on the same key shift function as the inverse. Right. One thing to point out is that is not 1 over sine x. Yep, so don't fall into that trap. That is not true. Right? So, what do we do to make L the subject of V is equal to pi r squared L? Divide by pi times r squared, did you say? Yeah. Yeah, when numbers are multiplied by each other, like those two, we can treat them in, move them together. If you're uncomfortable with that for the time being, divide by pi first, then divide by r squared if you want to. But because they're multiplied together, we can divide by that whole term and move them in one go. So divide by pi r squared, we end up with, and I'm going to put my L on this side, V over pi r squared. Simple as that. Yeah. So if you've got another bracketed term and there's a plus and minus inside those brackets, so if they're multiplied by the L, we can shift the whole bracketed term in one go. Have to keep the brackets in that case. Here we didn't keep any brackets because it's not necessary. Although they are implied by this line that there are brackets around there. It is V divided by all of pi times r squared. Alright? All okay with that? No questions? Make U the subject. So this is one of Newton's equations of motion. V is equal to U plus A T. Make U the subject. Yeah, you can, because they're multiplied together. You can treat them together. So we're going to divide by AT. Is that what you're saying? Oh, sorry. Minus AT. So we get U is equal to V minus AT. Alright. Can I move on? Fairly easy so far. In a right angle triangle having sides x, y and hypotenuse z, Pythagoras Theorem states that z squared is equal to x squared plus y squared. So we're talking about a right angle triangle where that long side is z. Yeah, and his law says the sum of the squares, the square on a hypotenuse is equal to the sum of the squares of the other two sides. You're all familiar with that, I would think, from GCSE mathematics. Transpose the formula to find x. Subtract y squared. So we end up with z squared minus y squared equals x squared. Yeah. Square root both sides. So x, so if we square root x squared, cancel, put that on there, do that, do that, cancel. X is equal to square root of z squared you do that enough to get some right traffic. Okay, everybody happy with that? So we cancel out square terms with square roots. Transpose the formula to make A the subject. We've got a squared x plus a squared y over r. What makes A the subject? We're going to start with that one. Multiplied by r is a half decent start point. So on the left hand side we get P times R, no, P is equal to a squared x, a squared y. Over. If I divide by y, I have to do this. Right? So you're going to say, divide that by y, fair enough, but I have to divide all of this by y. Has that helped? So it'll cancel that y out there. So what we'll effectively have here is a squared x over y plus a squared. Right? So you're starting your division before you've solved your addition. Everybody see that? Alright? You've got to divide the whole of this side. If you divide that side by y, that's the whole of this side, and that will cancel that y term, but that term being an x doesn't cancel. Yeah? You can't do that. Divide by what? X. If you divide by xy, xy, for a start they're added together, effectively, or they're terms that are added. But if you was to do that, you'd have this over xy plus that over xy. Not solved. The x's would cancel this side, the y would cancel that side. You see? Alright? If you square root a squared x, yeah, what you get is a Alright? So no. Add what together? No. Well, they are added together, but you can't. What? So you're saying you end up? What are you saying if I add those two terms together? What are you saying I end up with? They are added together now. So are you saying can I write 2a squared plus x plus a, or something similar? You completely forgot one skill that we developed week before last. What's common to both parts of that side? So we're going to factorise. Yeah, we can write p times r is equal to a squared, outside some brackets, x plus y. Have we still got the same thing? If we multiply the brackets out, we've got to do a squared times x plus a squared times y. Okay? But now, we've only got one a term. So we're winning the battle. What can we do now? Divide by x plus y. We can divide by the whole bracketed term. Yeah. So we can go, and I'm going to put my a squared on the left-hand side, the natural place to have the subject now. PR divided by x plus 1. How do we finish it off? Take the square root of both sides. A is equal to the square root, and you've got to do the whole thing. So it's PR over x. Yep. So you've got to stop where there's an opportunity. Factorise. And that's usually what you're going to have to do. Quite often what you're going to have to do, if you've got two or more lots of the term that you're trying to make the subject, you need to be looking for a way to factorise. This skill will only come with, there really is no replacement for you practicing, working on it. Alright? Because that's the only way. Boring as it might be, that is the only way. So, in your handouts now, on the page after that problem, you've got some solving equations to have a go at. The numbers in the square brackets are the answer you should get. Okay? And on the following page, there's some opportunities for you to practice rearranging formula. Okay? So, rest of the session is open for you to do that. Work together and help each other. Ask me questions if you get stuck. Okay? Next week we'll move on to something different. Start looking at some other engineering stuff. Alright?